So we can show the shape of molecules by using models. So like in this case, we have carbon which has 4 electrons, and hydrogen which has a single electron. Normally when they combine to form a chemical bond, each one will bring in its electron, so that in the end carbon has 1, 2, 3, 4, 5, 6, 7, 8 electrons. Each hydrogen has 2 electrons. So the question is, what is the shape of this molecule? Normally we use models to show the shape. So we use models to show the shape of molecules. So we have 2 types of models, that is ball and stick model. This one, you have a ball here, you have sticks that connects the two, and space filling model. So they can ask you, they can just show you a diagram and say, what is this model? So this is a space filling model. So this model is showing methane. So a methane is shown here 3 ways, but here also is shown as a model. So let's take note of these 2 models, ball and stick and space filling model. Here we are just repeating about covalent compounds, and also take note of these. Double covalent bond has 2 pairs of electrons shared. So 2 pairs means 4 electrons. Triple covalent bond has 3 pairs. 3 pairs means 6 electrons, because each pair is 2. So also write that down. But when presenting molecules, we use symbolic formulas. So what is a symbolic formula? Need to take note of this definition. A symbolic formula is just a shorthand representation of molecules. If I say carbon dioxide, that is the full name of the molecule. The symbolic formula is carbon dioxide. So this is symbolic formula. But we also present things like formulas, structures. All those are symbolic formula. We have 3 types of symbolic formulas. We have electron dot formula, we have structure formula, and we have molecular formula. So if they ask you, mention or state the 3 types of representing symbolic formula, know that the first one is electron dot formula, write that down, structure formula, and molecular formula. So these are the ways that we can present our symbolic formulas, and we will see what they mean the next slide. All right, now let's think about these atoms. And we are saying a covalent compound. A covalent compound forms by sharing of electrons. So let's take hydrogen and hydrogen. If we take hydrogen and hydrogen, each hydrogen has its own electron. Now, if you put them together so that they share, because they have the same power of sharing, the two electrons will be in between the two hydrogens, because they will pull the electrons using the same amount of force. So same, or I say similar atoms. I'll say similar atoms pull electrons with same amount of force. So because of that, they form non-polar covalent bond. What does non-polar covalent bond? Non-polar covalent bond means the electrons are in between the two. They are exactly in the middle between the two bonding atoms. Like if we calculate the distance from here to here and the distance from here to here, the distance will be the same. That's what it means. It means nonpolar will not have what we call a partial charge. So they will not have a partial charge. We will see what this means when we talk about the polar covalent compound. Now, how do we represent them? This is a hydrogen molecule. We are representing it using an electron model. So this is an electron model where we indicate a stick here is a structural formula, and where we just write the symbol and a number is a molecular formula. So let's take note of that. If we go to hydrogen and carbon, you see this is hydrogen carbon, hydrogen carbon, hydrogen carbon, hydrogen carbon. Hydrogen and carbon also will pull the electrons using the same power. Although hydrogen and carbon are different atoms, but they pull the electrons with the same force. So I'll say hydrogen and carbon pull electrons with the same force. So because of that, they are non-polar. So if you see a chemical bond between carbon and hydrogen, that compound is non-polar because hydrogen and carbon will pull electrons with the same force. So the electron will be in between the two. So this is a model. This one is a model representation. This one is a structural formula. This one is a molecular formula. Now, what about polar covalent bond? So in a polar covalent bond, if the sharing between two atoms is unequal, the covalent bond is described as polar. So let's take an example. If you have hydrogen and then oxygen and then another hydrogen here. Let me draw it in a good way. So let's suppose I have hydrogen here, I have oxygen here, I have hydrogen here. That's how a molecule of water is written. So oxygen has more ability to pull electrons than hydrogen. So oxygen has more ability to pull electrons than hydrogen. So you learn maybe in another class why that is the case. So because of that, the shared electron will be close to oxygen. What is this doing? So the shared electron will be close to oxygen than to hydrogen. So what happens? What happens is where the electron is, it has what we call a partial negative, because the electrons are negatively charged. So this part here up here becomes partial negative. Now this part, because the electron has been pulled to this side, it becomes partial positive. So this is how we write partial negative, partial positive. And because of that, this molecule will be polar. So the electrons are moving towards that side, which means this side will be positive, this side will be negative. So having two sides with different charges means the molecule is polar. So this is polar covalent. So let's take note of that. These are the models. The electron model. This is the electron model. Take note of this. This is the ball and stick model. This is the space filling model. I'm sure that you'll be asked about these models. So what is a polar covalent? A polar covalent is formed if the sharing between two atoms is unequal. So polar covalent forms when the sharing of electrons between two bonding atoms is unequal. That's how we form a polar covalent. While when the sharing is equal, that's covalent, non-polar covalent bond. Now, let's think about water again. If you talk about water, we have oxygen and then hydrogen and hydrogen. Say here we have oxygen, hydrogen, and another hydrogen. And here we have oxygen, hydrogen, and another hydrogen here. So what happens if water, I said that this part is partial positive, this part is partial negative. When you bring them close together, there will be an attraction between the two. The same thing, there will be an attraction between this one and that. there will be an attraction between this and that. They are not touching, they are not forming a chemical bond like we saw. They are not sharing electrons at all. They are just attracting like magnets. So the attraction between hydrogen and oxygen in this case is known as a hydrogen bond. So this one is hydrogen bond. So what is this hydrogen bond? A hydrogen bond occurs between a slightly positive hydrogen atom, which is this one, of one molecule, and a slightly negative atom of another molecule. So this is a slightly negative atom of another molecule, or between atoms of the same molecule. So you can see this is slightly negative, this is slightly positive. There are 3 atoms that work with hydrogen bonding. So 3 atoms that work with hydrogen bonding. So I'll write down the 3 atoms. Oxygen. When a slightly positive hydrogen interacts with oxygen, they'll form a hydrogen bond. We have fluorine. When a slightly positive oxygen interacts with fluorine, they'll form a hydrogen bond. And we have nitrogen. So when a slightly positive hydrogen interacts with nitrogen, they'll form a hydrogen bond. So these are the only 3 atoms where you can form strong hydrogen bond. So let me show you what I mean. If you have HF and then you have another HF, so this is covalent bond, another covalent bond, but this hydrogen is slightly positive. This F is slightly negative. This hydrogen slightly positive, this F slightly negative. So you form a hydrogen bond here because it is one of these 3: oxygen, fluorine, and nitrogen. Then if you have any H, and then another H, N, H, what will happen is there will be a hydrogen bond between this hydrogen and between this nitrogen. So this is slightly negative, this is slightly positive. That's how we form a hydrogen bond. But if you have H and Cl and H and Cl, here there will be no hydrogen bond, no H bond, because Cl is not one of these 3. So here you have H bond, here you have H bond because there's nitrogen, but here you have no H bond. Here for water you also have hydrogen bond. So that's it about hydrogen bond. And with water, hydrogen bond is really important. Water has very strong hydrogen bond. That's why it has high boiling point. So I'll just write here, and you should write that down. Water has very strong hydrogen bond. As a result, water has high boiling point. So write this information down. Here we are also showing how we represent atoms. So atoms can be represented by electron dot formula. So if you see something that has dots like this, know that that is electron dot formula. You just need to memorize this. Or just a structure formula. So structure formula does not have the dots, it just have the sticks. This is a stick formula or structure formula. Or molecular formula. So if I ask you, I can show you diagrams like this and say which one is electron dot formula, which one is a structure formula, which one is a molecular formula, right? So the questions that can come on your exam is identify one electron dot formula from these diagrams. 2. Structure formula. And 3. Molecular formula. So you can be given a multiple choice. So a molecular formula, just put the ions and the numbers they have. Like here N has 1, so we don't put 1. So NH3. H here has 2 and oxygen. Carbon has 1 and 4 oxygen. That's molecular formula. While a structure formula, you connect them using these sticks. While dot, you just put the dots. So take note of that. So and study these. I think these can come on your exam. So you just study the way they are here on this table. Ooh. Now let's talk about water. So water comprises 70% of living matter. So this percentage is important. Take note of it. And water is polar, as we saw earlier, because it has partial positive. So if you write a water molecule here, this one is partial positive, and partial negative. So electrons will move towards the oxygen because oxygen is pulling the electrons towards itself, therefore making water polar. And here we are just showing again what is happening to hydrogen bonding. You can see here the hydrogen interacting with oxygen. Oxygen here interacting with hydrogen. Hydrogen here. Oh, what is happening? Let me just make it big. So the same hydrogen interacting with oxygen. Hydrogen here interacting with oxygen here. That's hydrogen bonding. So they can show you and ask you, what is this? You just need to be able to say, oh, this diagram represents hydrogen bonding. So diagram represents hydrogen bonding. What are properties of water? So just memorize these properties. It is a universal solvent. Universal solvent means a lot of things can dissolve in there. So now let me use a different ink. So as a universal solvent, a lot of things can dissolve in water. That's what it means when you say universal solvent. A solvent is something that dissolves something. So solvent is where things are dissolved. Like if you dissolve salt in water, water is a solvent. So water is a universal solvent. It is a liquid at room temperature and body temperature. So water molecules are cohesive. It means they attract each other. Water molecules attract each other. They are cohesive. That's what cohesive means. And they have high specific heat. So you need to put a lot of heat for water to change its temperature. That's what it means. So need to put enough heat for water to change its temperature. So write down all those. Just a high specific heat means you need to put enough heat for water to change its temperature. It also has high heat of vaporization. You need more energy. So need more heat to change water to vapor. That's what it means. And water is less dense when frozen, so ice floats on water. Yeah, ice has bigger spaces than liquid water. So because of that, therefore, ice is less dense than water, and because of that, ice will float on water. So like ice really has bigger air spaces. So when you put ice in water, the ice will have less mass because some of it is just the air, while water has very small air spaces and will have more mass than the ice. So what will happen is, if you are using the same volume, the density of ice will be less than the density of water, and therefore ice will float on water. So when we think about water, also we think about acidic and basic solution. So water has a formula, H2O. Now if you want to write a structure of water, you can write it as OH, OH, or HO and H, if you want to write the structure of water. Or you can write a structure of water as O, H, and H. So when you have water solution, what you have is this water there in these structures. So what happens? When you have a neutral water, in neutral water, you have water as H2O or HOH or HOH. So you have water in these forms. But there is a small amount of water where this one is cut and this one is cut. So when this one is cut, we also have H plus and OH minus. So HO minus, which is OH, the same thing. This is the same thing as this, and H plus. So these are ions from water. Ions from water. All these are ions from water. So if you have a neutral water, in that neutral water you have the water itself that is not dissociated, and then you have dissociated water. So dissociated water is water that has become ions. Dissociated water. Now, with this dissociated water, neutral water has the same number of H plus and OH minus. So if you have the same number of H plus and OH minus, that is neutral water. So if someone asks you what is a neutral water, you just say neutral water has the same number of H plus and OH minus. This neutral water will have a pH of 7. Now, what about acidic water? Acidic water has more H plus than OH minus. So I'll say acidic water, in acidic water, H plus is greater than OH minus. So in acidic water, the pH is less than 7. So think about it. Acidic water has more hydrogen ions and the pH is less than 7. So if you see something, e.g., if you see something like pH is equal to 2, that one is acidic water, because pH is less than 7. What about basic water? Basic water has more OH than H plus. So I can say basic water, H plus is less than OH minus. This means more OH minus. And for that water, pH is greater than 7. So if something has a pH is equal to 8, that one is basic, because pH is greater than 7. So this is what we are saying. When you have water, you have the full water molecule here, full water molecule in them, and you have ions in there. So H plus ions and the OH minus ions. So what matters is how many of H plus and how many of OH do we have for us to call it acidic or basic? So what are these acidic solutions? Acidic solutions have a sour taste. They release hydrogen ions when they dissociate in water. So an acidic solution, by definition, must release hydrogen ions when they dissolve in water. So acidic solution, that is definition, right? Release hydrogen ions when they dissociate in water. So hydrogen ion is H plus. But also they have a sour taste. Examples are lemon juice, coffee, and vinegar. So what does it mean when you say release hydrogen ions? For example, HCl is an acid. When you dissolve HCl as an acid, what will happen? The HCl is going to release this hydrogen. So you have H plus and Cl minus. So as you can see, this one is releasing hydrogen ions. So it is an acid. As you can see, when I dissolve hydrochloric acid, so this is hydrochloric acid. This acid is found also in the stomach. When I release hydrochloric acid, I have these H ions released in water. That is an acid. What about basic solutions? Basic solutions have a bitter taste. They feel slimy or slippery to touch. So when you touch them, they'll feel like, oh, they are slippery. And by definition, they release hydroxyl ions in water. So basic solution, that is by definition, release hydroxyl ions in water. Actually, it's hydroxide ion, this hydroxyl thing. So the hydroxide ion is OH minus. Examples are ammonia, sodium hydroxide, and others. So what does it mean? If you put sodium hydroxide in water, you see this one, they will release this. So if you have NaOH, what happens is, in the end, you have Na plus and OH minus. So in that case, you have released this one in water. You can see here, the OH minus is being released in water. So the more the OH we have, the more basic the solution. So this one will have pH greater than 8. If we go back to the acid, this one has pH less than 7. Here it should not be greater than 8, but it should be greater than 7, not 8. So that's it about acid and base. Now to show acid and base, we use what we call pH scale. So the pH scale ranges from 0 to 14. And pH 7 is neutral. That's why at that point H plus is equal to OH minus in water. Equal amounts of hydrogen ions and hydroxyl ions. If you have pH below 7, we have more hydrogen ions and it's acidic. If we have pH above 7, we have more hydroxyl ions and it's basic. So here we have more this, here we have more this. Normally, the pH, the formula for pH is given by the formula minus log so this one is called the molar concentration of hydrogen. That's what the formula for pH is. So if you have the concentration of hydrogen as this given here, to calculate pH, what you do is minus log 1 times 10 to the power negative 6. The answer will be 6. So the pH of that solution is equal to 6. If you have this amount of hydrogen ions in water, the pH will be minus log 1 times 10 to the power 8. And the answer will be 8. So the pH will be 8. That's how we calculate the pH. But if you have more questions on this, you can ask, we can talk about it. I think that's where the lesson ends for today. Thank you, Mama. Oh, I forgot this part. So this is just the pH scale. And you need to learn how to use it. The more acidic ones, so the more acidic, the smaller the pH. More acidic means smaller pH. Here, less acidic, which is basic, means big pH. And if you have questions also, you can ask about this. I think this is where we end our lesson. Nope. I think the last part is buffer solutions. So buffer solutions are used to minimize changes in pH. So if you want the pH not to change, you use buffer solution. So they minimize changes in pH. The body has a lot of them. So the body has a lot of buffer solutions to maintain what we call physiological pH. Because if the body just changes its pH anyhow, we'll be in big trouble. So because of that, we use what we call the buffer solution. And if you have any questions on this, ask me, we'll go through it. Thank you, Mama, again.